All right, let's go through the basics real quick so Shane can explain how the stars work. Right, so this is you. This is how you perceive the sky, hemisphere around you. Nothing groundbreaking here. Everyone agrees on both models, as far as I can tell. On the globe Earth, this is exactly the same. It's the basis for the creation of the globe model in the first place. Not a physical dome running around with you, not going to touch other domes, right? The movement that you see happening, you think is because of curvature and no other reason. Even though every day you see other tall buildings, mountains, people, street lamps, everything in the world recede into the horizon proportionate with distance as a facet of perspective. We're just saying the stars are doing the exact same thing. The globe position, if you didn't know, is that actually the stars are doing the same thing, but for a totally, completely different reason than everything else in the known universe, and that's called curvature. So, on where we go. Right? You guys think, again, it's happening because of all those things is different? It's the same but different? No. But we have a completely solid, math-based, logically cohesive alternative, right? Our radius, of course, being a facet of the limits of perspective. Absolutely sound, mathed out, right? Makes total sense. You can derive the radius back from the optics of the human eye. You can also play with proportionalities on the radius criterion to do the same. So a completely solid, logically cohesive, math-based alternative application of what you've been told is the radius of Earth is the radius of the limit of your vision. So, how do you see celestial objects? Well, like this. They appear in the hemisphere around you and then appear to move, either of their own accord, 15 degrees per hour, or with you as you go across the axis here. Right? Moves 1 degree in the direction of movement as you move 69.07 statute miles in proportion with your direction of movement. That's all we're saying. And here's just an orthographic view of stellarium showing you the same thing, except my star isn't moving. This is just a 15 degree per hour rotation sped up over a person with a celestial sphere of globe proportions around the observer on a flat plane. Let's just do a quick walkthrough about how the stars and the celestial poles work on flat Earth. So to start, let's just assume that you see in globular dimensions, meaning you see in a hemisphere around you on a flat plane up to the dimensions prescribed by the globe. So in a sphere or half sphere of radius 3959. If you were to take a circumference of the circle of the limit of your view, it would be about 24,901 statute miles in a circle. Apply this to the celestial heavens, and we get a latitude-dependent pole around which things appear to rotate in the north. Circumpolar stars in the north. Here we have a 45-degree tilt. Someone is in northern latitude looking at the stars. This is what they see. Polaris, right about at an angle, not directly at the zenith, not directly at the equator. So going to the equator, you start to see both celestial poles pop up. Now, this is because the optical convergence known as the south pole starts to pop up. If you look back over here, only right about here is when you get far enough away from the center with your hemispherical limit of view to, first of all, lose the original only center of rotation. There is only one rotation of stars. Interferometry, every measurement ever taken of motion, has only registered one source central motion. All the interferometers have to be aligned to this source of rotation or motion. They cannot be aligned to any other. It is only one, singular. So when you get far enough away from this singular source of rotation, your limit of vision, judging by the example of crepuscular and anti-crepuscular rays, which would appear to bend what is flat light or parallel light above you, it would appear to bend that parallel light into a dome around you, and that your vision does the same thing just to the nighttime sky. It only makes sense that you'd experience the same thing at night as you do during the day. So during the day, if your vision is bending these parallel sun rays above you and they're arcing them into convergence points behind you that they're not really doing, your perspective is doing that, then that's all that we're saying is happening at night. Your perspective is taking these long star trails that are emanating from a singular source and spreading outward, and it's warping it into a concentric or warping into a counter convergence point produced by optics only when you get to the equator, only when you get far enough away from this rotation. Okay, And when you go further south of the equator, you get the optical convergence point known as the South Pole popping up because it's latitude dependent. And that would be the point around things which appear to rotate going forward. Right, now to take it out, to make it a little bit bigger, back it up. Again, if you're under the North Pole at the zenith, this is what it would look like. Everything spinning around you like a perfect hemispherical dome. Oh, and real quick, it should be said, this is not to scale. And my model of the dome is much bigger, just to show that scale, but for all intents and purposes, it represents the globular dimension. So it represents a dome of radius 3959. It's not in scale in proportion to the map around it. We'll go over that later, but just so everyone knows. Notice the similarity to a globe. Right? If you're standing right underneath it, this is what you'd appear to see. Everything rotating around you. Now, if you move your observer just a little bit, say, halfway between North Pole and the equator, about 45 degrees, you get the apparent rotation convergence point appear to rotate. It moves about here. Go back to the equator from this side, and we get to see the same thing. Equatorial star trails, where both poles appear to be visible, but neither one really is. They just be equatorial. Both appear to be below the horizon. Now, you go a little bit southward. You're far enough away, again, from the central rotation. You're far enough away from this where you can no longer see it. That's why it appears to dip below your horizon. 6,218 miles is the distance to which you can see that above the horizon. When you pass that distance, you can no longer see it. It's appear to set. It's over here. And now you have the counter convergence point known as the South Pole, the optic convergence, appearing to pop up and is now latitude dependent inversely, and is now the point around which stars appear to rotate in the south. Again, latitude dependent. So it's maintaining the same degree of latitude, the same elevation depending on your latitude in the south. The same relationship that Polaris has with elevation angle, that is to say synonymous with, the south optical pole convergence remains the same relationship in the south. So, again, maintaining directionality here, of course, has to be maintained in a circle around the central cylindrical axis for this map. That's why the compass is moving forever. It always is maintaining the relationship to the center. Okay, we're maintaining directionality on this map. Again, we're going to see our South Pole. We're going to overlay our stellarium orthographic view to see the exact same thing with a little bit more graphics. Okay? Stellarium uses the exact same model and the exact same method to portray the stars. In fact, it uses a stitched together grouping of azimuthal or alt-az horizon-based coordinates that they then modeled to create the celestial sphere. Right? Flat plane angles together, stitched together to create a bigger sphere that, when unraveled, would mimic a point-for-point correlation of the celestial sphere to geographic long latitude. That's all it is, guys. And the reason I can overlay the orthographic view of stellarium onto the flat Earth dome model is because they are doing the same exact transform. They are taking a personal alt-az coordinate system and transforming it to a celestial equator-based right ascension declination. So the celestial sphere, effectively, is just a conglomeration of alt-az observations of the sky from all over Earth that they stitch together into a ball contingent upon the correlative relationship of longitude and latitude to right ascension declination. So because for every star there's a ground position and a time, because of that one-for-one correlation, they have mapped these two spheres one-for-one to each other. But this is just taking a geodesic or geographic coordinate system or the celestial sphere and converting it to your local alt-az grid. That is all that is happening here, and that is all that is happening here. So when people try to misunderstand or misuse, it's just ignorance. Ignorance, same code process. Not the exact same code, it's written in different languages, but the same process of coordinate transform and translation making this run. That's all it is. Like geodesic to alt-az, boom. And then as you travel, the same translation, although applied differently, right? Latitude dependency. That's all it is.